Okay, let's look at the fourth problem next. This one says hydrogen phosphate and sodium hydroxide react to produce sodium phosphate and water. Then it says hint, keep the phosphate as PO4. Do not separate. What that means is, like in that last problem, if we kept the sulfates together, we could count them as one unit and not have to be counting sulfurs and oxygen. In this case, counting phosphoruses and oxygen atoms. Okay, so let's write our reaction, and then I'll show you here again what we mean by keeping these together and counting them as single units. Okay, so let's write the reaction. We have hydrogen phosphate. So here we go. Hydrogen plus 1. Hydrogen phosphate. So we got a compound here, and that's going to be our PO4. And this is the minus 3. So it's going to take 3 hydrogens for every 1 phosphate. And means we're going to do the plus sodium hydroxide, which is Li. Okay, sodium hydroxide. Get our parenthesis in there. That's a plus 1, minus 1, so it's going to be 1 of each of those. React to produce, or react to yield, so that's all meaning draw the arrow. Produce sodium phosphate. So we have sodium plus 1 phosphate, again is PO4 minus 3, so it's going to take 3 and 1, and water. Now, let me show you another little trick here. Okay, water, you guys know just from other schoolwork, okay, is H2O, right? 2 hydrogen and 1 oxygen oxide there, okay? We can also write water like this, HOH, hydrogen hydroxide. Same thing as water. These are identical components here, okay? So I'm going to write water in this fashion for this particular reaction because I'm looking and seeing, I've got hydroxides over here, and maybe that might help me count things when I go to compare my reactions to the products, okay? So depending upon what you have on either side is how you want to go ahead and choose which version of water you might want to use. Okay, let's use this one here, this HOH, and I think you're going to see why here in just a second. I'm going to squeeze it on my page there. Okay, HOH plus 1 minus 1, so 1 and 1 of each there. Okay, draw the line. Let's list now. So we've got hydrogens. Now I'm going to keep this phosphate together as one whole phosphate like we did the sulfate on the last problem. I'm not going to separate because I've got phosphates over here too. Okay, alright, so that's hydrogens, phosphates, we've got sodiums, and then we have hydroxides. I'm going to keep those together as units as well. Alright, so we'll list them in the same order: hydrogens, phosphates, sodiums, and our hydroxides. And I'll make my line a little longer there. Okay, let's go and count. We'll get our colons in here. Hydrogens, looks like we've got 3 hydrogens right there. Phosphates, now the 1 out there is what I'm paying attention to. We have 1 whole phosphate group there. Sodiums, we've got 1, and again we have 1 hydroxide there. All right, let's go to the other side, our product side, and we'll get our colons in there. Okay, let's find our hydrogens. We've got 1 hydrogen. Phosphates, 1 phosphate. Sodiums, we got 3 sodiums. And hydroxide, we have 1 hydroxide there. Okay, I think it's apparent that we are not balanced. We've got 3s and 1s, and then we have a different combination of 3s and 1s over there on that side. Alright, let's look at this and see how we might think we can go ahead and get ourselves balanced here. Let's see. The hydrogens, we have 3 and 1. Okay, so to fix that, if we put a 3 over here in front of the water, this hydrogen hydroxide, we can fix, let's go ahead and try that. I don't know if that's going to work or not. Let's just go ahead and put a 3 in there. Okay, so that fixes our hydrogens, and then we're going to end up with 3 times the 1 hydroxide, so that's going to give us a 3 hydroxide situation there. Okay, so we fixed the hydrogens, but we still got other problems over here. All right, let's look at the sodium now. On this side, we have 1 sodium atom over here, and then we have 3 on this side. So let's go ahead and see if we put a 3 in here, what happens. We put a coefficient of a 3 right in there. Okay, so that's going to change those sodiums to 3, and it changes our hydroxide also to a 3. Ah, look at that. It fixed our hydroxides for us. So while fixing the sodium, we also fixed our hydroxides. So we're 3 and 3, 1, 1, 3, 3, and 3, and 3. Okay, so we have balanced this reaction like we have the others. So we can say it takes 1 part hydrogen phosphate mixed with 3 parts sodium hydroxide to yield 1 part sodium phosphate and 3 parts of water. Okay, so in this reaction we talked about different possible ways that you can write water depending on what's most useful for you. Okay, and then we also talked about how we can keep, that little guy keeps coming up there. If we keep sometimes these ions as ions, it makes it easier to count them. We could separate out phosphoruses and oxygens and hydrogen, but we have this whole long list of elements there to try to balance. So this is just kind of a helper thing. If you identify ions, similar ions on both sides, okay, acting as ions there, keep them clustered together as single units. Right?